Ignition sequence starts.
Good morning, and welcome to Mission Control Houston. This is the International Space Station Flight Control Room, where a team of specialists is on console helping the Expedition 60 crew members as they work through the mission support and station maintenance activities on their daily schedule. A crew rotation on orbit is scheduled to start in just a couple of weeks, but Commander Alexei Ovchinin and his Russian, American, and Italian crewmates have been focused this week on station science research activities, and that's included a plant growth experiment from the United Arab Emirates.
Welcome to Space to Ground. I'm Leah Cheshire. Summertime might be coming to an end, but astronauts on the space station still have palm trees on their mind, and in the lab. As we look to go forward to the moon and on to Mars with Artemis, researchers are interested in learning more about how plants germinate in a microgravity environment. The United Arab Emirates Palm Tree Growth Experiment observes and documents root development of the date palm while in space. Evidence of healthy plant tissue grown in microgravity may support the possibility of future explorers growing plants for consumption and other purposes. Meanwhile, on terra firma, 3 crew members are finishing up final preparations prior to launch. After completing ceremonial activities and mission briefings, the Expedition 61 crew of Jessica Meir, Oleg Skripochka, and Hazza Ali Al-Mansouri departed the Gagarin Cosmonaut Training Center in Star City, Russia, and arrived at the Baikonur Cosmodrome in Kazakhstan. Here, they'll finalize pre-launch training before beginning their journey to the space station with a liftoff on the Soyuz MS-15 spacecraft scheduled for September 25th. This week's question is from Sohan, who asks how the space station is protected against radiation and debris. Space station modules are made from an outer layer of aluminum, an insulation layer, a debris shield layer similar to Kevlar, and a second debris shield layer of aluminum. This amounts to protection against debris, micrometeoroids, and radiation, as well as it reflects the intense sunlight. Keep sending us your questions using the hashtag AskNASA. We'll see you next week.
The International Space Station's laboratory modules support experiments in a number of scientific disciplines for all kinds of research in which scientists want to remove gravity from the conditions of the test. For example, the flame design investigation, looking into the quantity of soot produced under different burning conditions. Now, this could generate data that leads to the creation of new burners that are more efficient and less polluting. There are other areas of scientific focus on the International Space Station, also taking advantage of the weightless environment, like physics and biology. An example, an experiment involving a device about the size of a thumb drive that contains human cells in a 3D matrix. Now, this may help scientists learn how the cells respond to stresses, drugs, and genetic changes. These devices are known as tissue chips. The International Space Station's laboratory modules are not the only place on the station that supports science research. Fact is, the outside of the station is a swell spot for experiments that are studying the Earth 250 miles down there. Out on the Kibo Laboratories exposed facility, there is a package pointing a laser light down at the tree canopies on the planet to study Earth's ecosystem for scientists who want to find out more about how it's changing.
Shining laser light on Earth's forests. Presented by Science at NASA. The International Space Station, or ISS, is sporting a new light fixture. The Global Ecosystem Dynamics Investigation, or GEDI, will beam down laser light on Earth from the orbiting laboratory to reveal more about our environment and how it is changing. NASA's GEDI sends laser pulses into tree canopies and precisely measures the light reflected back. The timing and intensity of light that bounces back to GEDI's telescope will reveal the height and density of trees and vegetation, and the vertical arrangement of the leaves and branches within the overall canopy. Dr. Ralph Dabaya, GEDI principal investigator at the University of Maryland, says, "This instrument will map forests in high resolution and 3 dimensions, revolutionizing the way researchers monitor them. Forested areas are an important part of our planet. Not only do forests provide a habitat for many species and a source of raw materials for human use, such as paper and lumber, they also play a key role in the Earth's carbon cycle. Deforestation and forest degradation, in addition to other types of forest disturbances, such as fires and insect outbreaks, lead to increases in atmospheric carbon dioxide. Forest regrowth sucks that carbon back down into trees and soils. Knowing how forests grow and change over time can allow us to better understand the contribution that forests make to Earth's carbon cycle and help people better manage this important resource. GEDI is the first spaceborne instrument designed specifically to perform sustained mapping of the spatial distribution of the carbon content of forests." Dabaya notes, "One of the most poorly quantified components of the carbon cycle is the net balance between forest disturbance and regrowth. GEDI will help scientists fill in this missing piece by revealing the vertical structure of the forest, information we really can't get with sufficient accuracy any other way. GEDI will provide scientists with insights into the amount of carbon stored in forests. When combined with current and historical records of changes captured by Earth-orbiting satellites, such as Landsat, this information will enhance the ability of researchers to identify changes happening across our planet. Researchers also will incorporate GEDI's observations, along with those of the EcoStress instrument on the station, with data from other current and future Earth-observing sensors. These data will address important questions about relationships between forest structure, function, composition, and changes in carbon content. Combining all of these data will allow researchers to gain an unprecedented understanding of ecosystem dynamics and the role plants and trees play in Earth's global carbon cycle. These new insights could be used in turn to improve models for forecasting future ecosystem changes, atmospheric carbon dioxide concentrations, and climate. GEDI was launched to the station aboard SpaceX CRS-16 on December 5, 2018. For more about how NASA uses the power of light to understand our world and beyond, visit science.nasa.gov.
Another goal of International Space Station science is helping us prepare for future human exploration of space. The rodent research experiment is a twofold investigation into the treatment of muscle loss during spaceflight, and it may have implications for patients on Earth who have muscle wasting diseases. The experiment studies the effectiveness of a drug compound, as well as the nanochannel drug delivery implant.
We're testing the drug as well as the device. Sarcopenia or muscle wasting is a big burden on the healthcare system currently. So The results from this study will provide us with valuable information on understanding the mechanism of action for the drug that we're testing. Now, the other unique aspect of it is the nanochannel delivery system that is implanted in the mice.
These nanochannel membranes are microfabricated with the same type of technology that you use for make computer chips. Because we have realized that if we take channels that they are that small and we use them as a rate-limiting membrane, we can achieve a very steady and controlled delivery of the drug without any sort of pumping mechanism on board of our implants. So that makes a very small, very effective implantable delivery system.
The big goal is that we're making humanity better and we're helping our generation and the next generations live longer and better. So at the end of the day, if we can accomplish that, it makes it all worth it.
The physical structure of the International Space Station itself relies on a series of trusses engineered to withstand the different forces that the station encounters in low Earth orbit. In this demonstration video, astronaut Ricky Arnold explains the significance of these resilient structures and the forces they're up against in microgravity.
Hey there. I'm NASA astronaut Ricky Arnold. Welcome aboard the International Space Station. Today we're going to talk about the Space Station truss. The truss segment is just about 100 meters from side to side.
A truss is a segment or part of the whole integrated truss structure. The trusses are used to support the 16 solar array panels, which provide energy for us, and radiators which get rid of excess heat that builds up inside the space station. The design of the truss involves triangles and beams, which can be seen on Earth in structures like bridges. Why triangles? Well, this is because of their unique geometric properties, their methods of transferring loads, and their spatial openness. Triangles are more rigid than rectangular shapes because they have fewer joints. The larger number of joints in a shape, the more prone that shape is to being impacted by shear forces.
What I'd like to talk a little bit about today is some of the forces that can act upon the truss. Well, the first force I want to talk about is compression force. And compression force is just like it sounds, two things coming together. So if we apply a compression force to the truss, what do you think is going to happen? Well, let me go ahead and do it. And you can see right here where the truss would bend. What do you think the opposite force of compression is? Yeah, it's going to be pulling apart. We call that a tension force. And a tension force is what's going to help maybe even rigidize the truss segment, but it also could potentially pull it apart. I'm not going to pull apart this tape measure because we probably need it later for some work we have to do.
Now, if you look carefully, this next force I want to talk about
is basically kind of like a twisting force, and we call it torsion. And even when I just let go of the tape measure, you can see it will actually start to happen a little bit. You can start to see, because the center of mass is actually right here, where most of the tape measure is located. And when I let it go, the tape measure itself starts to twist just a little bit. Finally, the fourth force
that can act along a truss segment
is that can occur at a single point where two opposing forces work on a single point along the truss, just like they can upon the Earth's surface. Think about some earthquakes. You can have a plate that is, or along a fault line where one side of the fault line is moving upward or being forced upward while the other side is moving downward. And that force in one point in opposite directions is called a shear force. And we can also have that happen on the truss segment. Something like this.
One thing to think about, where do these forces come from?
one force, even though we're up here largely out of the Earth's atmosphere, we do still have drag with the Earth's atmosphere, which can impart loads on or impart a force on the truss segment. Another, I already hinted at earlier, is crew working inside. We're up here, we're exercising, we're moving really heavy pieces of equipment around. So we have an amazing engineering team on the ground, and we have specific disciplines that their job is to monitor all the forces imparted upon the International Space Station. They keep track of all those various forces I talked about and where they could be coming from, the atmosphere, visiting vehicles, or even things that the crew are doing inside the space station, and to make sure that those forces aren't significant enough to cause any damage to this wonderful laboratory and living space we have up here in low Earth orbit. Thanks so much for joining me today. We'll see you next time. So long.
The International Space Station's role in preparing for future exploration involves being a testbed for the technologies that we'll need to make those future trips. Things like the water recovery system, which takes moisture gathered from a number of sources and turns it into safe, clean drinking water. Here's how it works. Things we're learning on the International Space Station are helping us get ready for the next steps in human space exploration. NASA's Artemis program will return astronauts to the moon by 2024 as a step in the plan to send people to Mars in the years to come. NASA's Human Research Program is doing research and technology development on ways to enable people to live and work safely and effectively out in space over long periods of time. One of the most challenging aspects of sending human beings out beyond low Earth orbit is dealing with space radiation.
For the journey to Mars, the Human Research Program works to project, assess, and solve the problems that astronauts have in space. Specifically for radiation research, the Human Research Program works to predict and mitigate the health effects of space radiation on astronauts.
I think one of the most challenging parts for the journey to Mars in terms of the humans and not necessarily the technology to get there is the risk of radiation exposure and the in-flight consequences of the exposure to radiation as well as the long-term health consequences of exposure.
There's two parts of radiation we have to protect the crew from. One is a solar particle effect, where there's a solar storm and these energetic particles stream out. Fortunately, we know how to protect the crew from that. We put them into a shelter that's shielded by lots of water. And actually, they're very short duration, hours to days at most. They can come out and continue with their journey. That's the one aspect of radiation we know how to protect against. The other, which we really don't have a firm handle on, is galactic, cosmic rays. These are highly energetic particles that come from all over the galaxy towards the solar system and Earth. You can't shield against these. They're so energetic, they rip right through all metals, all plastic, all water, and all cellular material. And as they rip through these materials, little electrons and protons pull off of them, and you end up getting a cascade effect of radiation throughout the materials. And sometimes going through certain materials causes a worse radiation environment for the crew than had it gone through other materials. So we try to design the spacecraft out of materials that shield the crew from these, but also do not produce more hazardous particles as a function of being impacted with it. So a lot of people think that radiation will keep NASA from sending people to Mars, and that's not what the current situation is. We have techniques, we've discussed ways of getting there faster. We know that we add these various mitigations up, that we can have a successful Mars mission, a healthy crew, and have them live a very long and productive life after their return to Earth.
There are 3 members of the Expedition 60 crew on orbit right now who launched to the station on the 50th anniversary of the Apollo 11 moon landing. That was the mission that made good on President John Kennedy's challenge 57 years ago yesterday to land men on the moon and return them safely to Earth before the 1960s were out. The realization of that challenge had a profound effect. Much of a generation of Americans were inspired to a lifetime of exploration that continues right up to today and tomorrow.
The exploration of space will go ahead, whether we join in it or not. And it is one of the great adventures of all time.
And no nation which expects to be the leader of other nations can expect to stay behind. But why, some say, the moon? Why choose this as our goal?
Why climb the highest mountain? Why, 35 years ago, fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade.
It's one small step for man, one giant leap for mankind.
Expedition 12 Commander Bill MacArthur with a greeting for his Expedition 11 counterpart.
Because of your work, because of the ingenuity, dedication, and entrepreneurial spirit reflected in this room and throughout the American space enterprise. Since the end of Apollo 11, we've forged incredible breakthroughs in our technology that have allowed us to go further, more safely in space than ever before. Let me be clear. The first woman and the next man on the moon will both be American astronauts.
If you'd like to get another look at any of the stories we feature today, you can. For instance, you could go to YouTube or Facebook, and there are the addresses. And while you're there, look not only at these features, but you'll find a lot of other things there about NASA and America's human spaceflight program. Since you're out on the internet anyway, I suggest check out Houston We Have a Podcast. Folks here at NASA talking about their work in all aspects of space exploration. We post new episodes every Friday, and today we have a special episode bringing you an interesting panel discussion about women in human spaceflight. It includes some ladies who work here today and others who worked here going back to the Apollo program. Check out their stories in today's episode by going to nasa.gov/podcasts. When you're there, you can also access all of our previous episodes, as well as the full library of all of the NASA podcasts, all of which you can also listen to on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control, Houston.